Hello friends, myself Dr. Vanita Raut working as an assistant professor in physics at ASC College Ramannagar. Today I am going to deal with topic binding energy curve. In this topic I am going to discuss subpoints as introduction, binding energy per nucleon and a detailed explanation of binding energy curve. Atom is neutral in nature. The central core of the atom is called nucleus. The nucleus possesses almost whole mass of an atom. Nucleus contains nucleons which contains neutrons and protons. Electrons are revolving around nucleus in various orbits. Atom contains protons and neutrons inside nucleus while electrons outside nucleus. The table shows comparison of these subatomic particles on the basis of mass, total number and charge. Here mass is expressed in atomic mass unit, kilogram and mega electron volt per c square. Mass comparison of subatomic particles shows that electron is the lightest particle while neutron is the heaviest particle. Mass of neutron is greater than mass of proton, which is greater than mass of electron. Mass of proton is approximately equal to 1836 times mass of electron. In an atom, there are Z number of protons, Z number of electrons and capital N number of neutrons. The charge on neutron is 0. Electron possess minus E charge while proton possess plus E charge. As the total positive charge inside the nucleus is exactly balanced by negative charge electrons outside the nucleus. Hence, net charge on atom is 0 and thus atom is electrically neutral. Since protons are the heaviest particles in atom and protons lie inside the nucleus. Hence, nucleus of an atom is the part of an atom where whole mass of an atom is supposed to be concentrated. The dimensions of nucleus is about 10 raised to minus 14 centimeter. There are various properties of nucleus. The properties of nucleus which are studied when it is in ground state are called as static properties, and binding energy is one of the most important static property of nucleus. Binding energy is the energy required to break the nucleus into its constituent nucleons, that is, neutrons and protons. The term binding energy is also used to indicate the energy that would be required to form a nucleus from separate protons and neutrons. Nucleons are held together in nucleus by strong attractive force. Therefore, to break a nucleus among nucleons, one has to apply energy against this attractive force. If delta M is the mass defect, then binding energy EB is equal to delta M into c square. If protons and neutrons are assumed to be the elementary constituents of the nuclei, then binding energy of a nucleus is defined as binding energy is equal to into bracket ZMP plus A minus Z Mn minus Mn bracket complete c square, where Mp is the mass of proton, M small n be the mass of neutron and M capital N be the mass of nucleus. Here Z and A minus Z represents number of protons and neutrons. Binding energy curve is the plot of binding energy per nucleon as a function of mass number capital A. It provides information regarding stability of the nucleus. Figure shows binding energy curve. The binding energy curve at first rises steeply. It shows few peaks at A is equal to 2, 4, 8, 12, 16 and 20. After A is equal to 20, it attains a maximum value equal to 8.79 mega electron volt for A is equal to 56 corresponding to the iron nucleus. The curve after A is equal to 56 shows dropping for higher values of mass numbers, becoming binding energy per nucleon values 7.6 mega electron volt corresponding to uranium nucleus. Binding energy EB is small for light elements. This is because for light nuclei, the number of nucleons is small. Thus, nucleons are on the surface of nuclei, causing surface tension like opposing forces. The peaks obtained at A is equal to 2, 4, 8, 12, 16 and 20, the mass numbers for these cases are even, so that nucleus has tightly bound structure which increases their binding energy. The nuclei having mass number 56 or near are the most stable. This is because neutron number for these elements is almost constant. For heavy elements, binding energy decreases because for heavy elements, the number of protons increases, which resultantly increases the Coulomb's force of repulsion. On either side of binding energy maxima, the nuclei are less stable. This is because they possess less binding energy per nucleon, which means it is easier to separate the nucleus in its constituent nucleons. That is, the nucleons are not so tightly bound together as that as the maxima. Maximum binding energy per nucleon is at about A is equal to 50. In this region, the nuclei will be more stable because they possess a greater binding energy per nucleon, which means it requires more energy to lift a nucleon from the potential well of the nucleus. Thus, in order to achieve stability, light nuclei undergoes fusion reaction to form a stable nuclei having more binding energy per nucleon, while the heavier nuclei, that is big nucleus, it disintegrates. Each nucleon become a member of small nucleus, so that binding energy per nucleon increases. The fission occurs when the original nucleus splits into two approximately equal wholes. Radioactive disintegration occurs when the original nucleus loss and alpha, beta or gamma particles. When these emissions occur, the nucleus becomes lighter than that of before, so that the binding energy per nucleon increases and the nucleus is more stable. Thank you.